This is going to be really quite straightforward. So a probability is to do with the total number of students. The total number of students are 15. So this is simply going to be 6 over 15. And for this course, you do not need to simplify fractions unless they explicitly ask you to do so. So only do this if you're really confident. If you write 6/15 and then you write your answer, your final answer is 3/5, you're not going to get the mark. So the next question is to do with finding the probability he will choose a female student 8 times. So it's to do with teaching some class 20 times and finding out the result 8 times. Now, because we're picking out of 2 options, we have got 2 options in this case. We're not dealing with gender neutral, we're dealing with female and we're dealing with male. So we're going to talk about this being a success and a failure. Or another way of thinking about this could be a success and not a success. And whenever you've got something which is a success and something that's a failure, we have to think of the topic binomial. And the reason for this is because it's a bit like a tree diagram question in the sense that we are looking for the results from a tree diagram. However, because we have got so many different sort of classes we're analysing a class happening 20 times, we cannot draw a tree diagram with 20 sets of branches. This is simply not possible. So because this is an exact number, we need to select the PDF option. So we're going to press enter. How many trials? So the trials is how many times does this repeat in the experiment? Well, there are 20 trials. The probability he will choose a female, well, we've already calculated that. We said there are 6 out of 15. So the probability is going to be 6 divided by 15, nice and easy. The x value is how many times we want that probability to occur. So we want it to occur 8 times. We're just substituting the numbers into this menu. And actually, the hardest thing about it was finding where the binomial was. That's the only difficult thing about this question. Press enter. Fantastic. We get 0.179705. So because this is such an exact number, it's not going to have a massively high probability. What you've got to remember is if your calculator doesn't look like mine when I press binomial PDF, doesn't have a nice layout like this, you need to go to your mode and you need to change your mode slightly. Mine seems to be in maths print at the moment, but normally classic really helps this mode. And obviously all these calculators differ very slightly depending on what kind of calculator you've got. So my calculator seems to prefer to be in maths print mode. But if it isn't in the maths print mode, you can actually do this question all right. I'm just going to explain how it's going to be slightly different. If it's not in the maths print mode, for my calculator, you are going to have to remember what each of these numbers are, which is a little bit more challenging. You have to remember the first number is the trials, then put a comma. The second number is the probability, which is 6 divided by 15. And then the third number separated by a comma is going to be the number of outcomes, which is 8. That might be a little bit more challenging, so just change around with the modes, maths print or classic, and see what your calculator prefers. Find the probability he will choose a male student at most 9 times. So we're going to have him teaching a class 20 times. And we're going to have a whole host of options he can have. He could pick a male student from 0 to 20 times. So we want to find if he picks at most 9 times. Now, if it says at most or at least, you're going to be using the CDF version of your calculator. And let's talk about how that works. Go back onto the distribution, and before I do that, I am going to change it back to classic because this is what I prefer rather than memorising it. We're then going to go down to, this time, the binomial CDF. And the reason why I prefer this is because for this question, what we need to think about is, if it's at most 9 times, it's going to be the probability of picking it once, twice, 3 times, 4, 5, 6, 7, 8, 9. So what we want to do is we want to add the probability of picking once, twice, we want to add them all together. So the CDF mode will add them all together. So this is what we would do for the at most question. Now, the at least are a little bit different. So for example, if it said at least 9, that's going to be a harder question. And we might talk about that in a moment. So for this one, let's have a look at the CDF. For some reason, my mode seems to be switching between what I want, as I really like the classic, but it doesn't seem to be lining up with this app online. So let's cross our fingers and hope it's going to happen now. Going down to part B. Excellent. So the number of trials. Trials is still the same, 20. Male student, this is different. This is a common error. People forget to change this number here. It's going to be 9 out of 15. The X value is going to be 9. We're going to expect quite a high probability because we've got lots of options. 0, 1, 2, 3, 4, 5, 6, all the way up to 9 students. 0.1275. Well, this is not quite as high as I expected it. And the problem with this, or the probable reason why this could be, is because actually it's really probable you're going to pick a male student. It's 9 out of 15. So this is why this probability is perhaps lower than what you would expect. So that would be our answer for this. And now let's say if we had to change the question. Let's say we change the question to what I wrote earlier, and it said at least 9. Or we could change it to at least 10. So the previous question represented 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So at least 10. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Actually, I've realised now why I got confused with this probability. I thought this probability would be higher because I thought the maximum number would be 15. But pause the video and have a think why the maximum number isn't 15. Welcome back. The reason why is because the trials are 20. So I was mixing up the number of trials with the number of people in the class, and actually the number of people in the class is irrelevant. So if we wanted to think about the probability of picking at least 10, it would be 10, 11, 12, 13, 14. And what the CDF does, it can add together 0 and 1, 0, 1 and 2, 0, 1, 2 and 3, 0, 1, 2, 3, 4, because this is to do with cumulative adding. But it can't add together just 10 to 20. So for the at least questions, what you have to do is 1 minus the probability of the at most situation. So you have to look at the inverse. So these are complete inverses of each other because between both of them, they add up to, or they include all the numbers between 0 and 20. So for the answer for this question, we would just do 1 minus the answer of the previous question, and it would be as easy as that. So before we end this video, what we're going to have a look at is the answers to this question 1 through to C and just double check with the workings out that we were along the right lines. So scrolling through to question 2, we are going to have the following. These absolutely match up here. 0.18. And finally, we're going to have 0.128. So for this, what you really need to do is identify you're selecting the probabilities x equals to 8. And you'll get 1 mark for that. And you get your second mark for the answer. Similarly, for this one, you get 1 mark for working out the probability of male. Well, we've already done that. And you get your second mark for identifying the correct inequality. So make sure you're writing the P and you're identifying the X. So that is really quite a straightforward question. I hope that helps you, and let me know if you need any help.